We have understood how each school of thought in psychology has developed, prospered for a time, and then, with the exception of psychoanalysis, became part of mainstream contemporary psychological thought. We also understood that each movement drew strength from its opposition to an earlier school, and then, when there was no longer a need to protest, when the new school had ousted its opposition, it ceased to be a new revolutionary movement and became the established order, at least for a while. Each of the schools we discussed made substantial contribution to psychology's evolution: structuralism, functionalism, and Gestalt psychology. This is even true for structuralism, even though it left little direct imprint on psychology as we know it today. There are no longer structuralists of Titchener's sort in modern psychology, nor have there been for more than a century. Yet, structuralism was an enormous success in promoting the enterprise Wundt began, the establishment of an independent science of psychology, free of the strictures of philosophy. The fact that structuralism failed to dominate psychology for more than a short time does not detract from its revolutionary achievement as the first school of thought of a new science and a vital source of opposition for the systems that followed. Consider the success of functionalism, which also has not endured as a separate school. As an attitude or viewpoint, however, which is all its advocates hoped it would be, functionalism permeated American psychological thought, to the extent that American psychology today, in contemporary times, is as much a profession as science and applies its findings to virtually every aspect of modern life. The functional utilitarian attitude has indeed changed the nature of psychology. What of Gestalt psychology? It, as well, on a more modest scale, accomplished its mission, its opposition to elementism, its support of a wholes approach, and its interest in consciousness influenced psychologists in clinical psychology, learning, perception, social psychology, and thinking. Although the Gestalt school did not transform psychology the way its founders originally expected, it had considerable impact and can therefore still be described as a success. As noteworthy as the accomplishments of structuralism, functionalism, and Gestalt psychology are, they take second place to the phenomenal impact of behaviorism and psychoanalysis. The effects of these two movements, of behaviorism and psychoanalysis, have been profound, and they have maintained their identities as separate and unique schools of thought. We saw how behaviorism and psychoanalysis splintered into various positions after the days of their original founders, Watson and Freud. No single form of behaviorism or of psychoanalysis has won allegiance from all members of either school. The emergence of sub-schools divided the systems into competing factions, each with its own map of the path to truth. Despite this internal diversity, however, behaviorists and psychoanalysts stand firmly opposed to each other in their approaches to psychology. For example, Skinnerian behaviorists have more in common with the followers of Bandura and Rotter than they do with followers of Jung's or Horney's psychoanalysis. The vitality of these two schools of thought is evident in their continuing evolution. We have seen that B.F. Skinner's psychology was not the last stage in the development of behaviorism any more than Adler's individual psychology was the final stage of psychoanalysis. We also understand that humanistic psychology, although failing to make an impact as a separate school of thought, nevertheless influenced contemporary psychology through growth of the positive psychology movement. By the 1960s and the 1970s, two other movements arose within American psychology, and each shaped new approaches to the field. These movements are cognitive psychology and evolutionary psychology. In Watson's Behaviorist Manifesto in 1913, he insisted that psychology drop all references to mind, consciousness, or conscious processes. Indeed, the psychologists who followed Watson's dictates eliminated any mention of these concepts and banished all mentalistic terminology in regard to the mind, consciousness, or conscious processes. For decades, introductory psychology textbooks described the functioning of the brain, but completely refused to discuss any conception of the mind. People joked that psychology had lost consciousness or lost its mind, seemingly forever. Then suddenly, so it seemed, although the trend actually had been building for some time, regained consciousness. Words that once were banned were being uttered openly at meetings and appearing in print. In the year 1979, the American psychologist published an article titled Behaviorism and the Mind, with the subtitle, A Limited Call for a Return to Introspection, invoking not only mind but also the suspect technique of introspection. A few months earlier, the journal had published an article with the simple title, Consciousness. After decades of deliberate neglect, its author wrote, Consciousness is again coming under scientific scrutiny, with discussions of the topic appearing at entirely respectable locations in psychology's literature. In 1976, a few years before, in his annual address, the APA president told the assembled audience that psychology was changing and that the new conception included a refocus on consciousness. Psychology's image of human nature was becoming, quote, human rather than mechanical, end quote. When an officer of the APA and a prestigious journal discuss consciousness so openly and optimistically, it seems obvious that a revolution, another new movement, is underway. Revisions in introductory textbooks followed, redefining psychology as the science of behavior and mental processes instead of only behavior, a science seeking to explain overt behavior and its relationship to mental processes. It was clear that psychology had progressed far beyond the desires and designs of both Watson and Skinner. A new school of thought was taking hold. The mind was welcomed back into psychology. There were antecedent influences on cognitive psychology. Like all revolutionary movements in psychology, cognitive psychology did not spring up overnight. Many of its features had been anticipated. Interest in consciousness was evident in the earliest days of psychology before it became a formal science. The writings of the Greek philosophers, of Plato and Aristotle, of classical antiquity, deal with thought processes. So did the theories of the British empiricists and associationists, which we have discussed before. When Wundt founded psychology as a separate scientific discipline, his work centered on consciousness. He may be considered a forerunner of contemporary cognitive psychology because of his emphasis on the mind's creative activity. The structuralist and functionalist schools of thought dealt with consciousness, studying its elements and functions. Behaviorism, however, brought about a fundamental change, dismissing consciousness for about 50 years, or half a century. The purposive behaviorism of E.C. Tolman, which we have discussed earlier, was a precursor of today's cognitive movement. His form of behaviorism recognized the importance of cognitive variables and contributed to the decline of the stimulus response, or SR approach. Tolman proposed cognitive maps, attributed purposive behavior to animals, and emphasized intervening variables as a way to operationally define internal, unobservable states of consciousness. Gestalt psychology influenced the cognitive movement with its focus on organization, structure, relationships, the active role of the subject, and the important part played by perception in learning and memory. The Gestalt school of thought helped keep alive at least a token interest in consciousness during the years that behaviorism dominated American psychology. Another anticipator of cognitive psychology was the Swiss psychologist Jean Piaget, which we have not mentioned, but he was born in 1896 and he died in the year 1980. Piaget liked to eat stale bread with mayonnaise and garlic. He also permitted women to work in his laboratory, an unusual step to take at that time. Piaget wrote his first scientific paper when he was 10 years old and later studied with Carl Jung. Piaget also worked with Theodore Simon, who, with Alfred Binet, developed the first psychological test of mental abilities. Piaget later became important for his work on child development in France, not in psychosexual stages as proposed by Freud, but in cognitive stages. Piaget's clinical method of interviewing children and his insistence on highly detailed note-taking during the interviews were seen as a major inspiration for the famous American Hawthorne studies of industrial workers in the 1920s. Piaget actually did a lot of his work by observing the behaviors of his children. However, Piaget's work on cognitive development, which was published in the 1920s and 1930s, although highly influential in Europe, was not very widely accepted in the United States because of its incompatibility with the behaviorist position. The early cognitive theorists, however, welcomed Piaget's emphasis on cognitive factors, especially in regard to developmental psychology. As the ideas of the cognitive psychologist took hold in American psychology, the relevance of Piaget's ideas became even more clearer. In 1969, he became the first European psychologist to receive the APA's Distinguished Scientific Contribution Award. Because his work focused on children, it helped broaden the range of behavior to which cognitive psychology would be applied. When we find such a major shift in the evolution of a science, we know it is reflecting the changing intellectual climate as well. We have seen that a science, like a living species, adapts to the conditions and demands of its environment. What intellectual climate fostered the cognitive movement and moderated behaviorist ideas by readmitting consciousness? Once again, we look to thinking in physics, long psychology's role model, for it has influenced the field since its beginning as a science. Early in the 20th century, a striking new viewpoint developed within physics from the work of Albert Einstein, Niels Bohr, and Werner Heisenberg. They rejected the mechanistic model of the universe stemming from the days of Galileo and Newton and Newtonian science, the prototype for the mechanistic, reductionistic, and deterministic view of human nature, embraced by psychologists from Wundt to B.F. Skinner. The new look in physics discarded the requirement of total objectivity and the complete separation of the external world from the observer. Physicists in the 20th century recognized that any observation we make of the natural world is likely to disturb it. They would have to attempt to bridge the artificial gap between observer and observed, between the inner world and the outer world, and between mental and material. Thus, scientific investigation shifts from an independent and objectively knowable universe to one's observation of that universe. Modern scientists would no longer be so detached from the focus of their observation. In a sense, they would become participant observers. As a result, the ideal of a totally objective reality was no longer considered attainable. Physics came to be characterized by the belief that what was once thought to be objective knowledge is actually subjective and therefore highly dependent on the observer. This idea that all knowledge is personal sounds suspiciously what George Berkeley proposed 300 years ago, as we saw earlier, that all knowledge is subjective because it depends on the nature of the person that is perceiving it. Thus, our picture of the world, quote, far from being a genuine photographic reproduction of an independent reality out there, is rather more on the order of a painting, a subjective creation of the mind which can convey a likeness but can never really produce a replica. The physicists' rejection of an objective mechanistic subject matter and their concurrent recognition of subjectivity restored the vital role of conscious experience as a way of obtaining information about our world. This revolution in physics was an effective argument for again making consciousness a legitimate part of psychology's subject matter. Although the scientific psychology establishment resisted the new physics for half a century, clinging to an outdated model by stubbornly defining itself as an objective science of behavior, it eventually responded to the changed spirit of the times and modified itself sufficiently to readmit cognitive processes. Partly that was probably because of positivism, which dominated the first half of the 20th century. A look back at the beginning of the cognitive movement gives the impression of a rapid transition that undermines psychology's behaviorist foundations in a few short years. At the time, of course, this transition was not at all apparent. The change that now seems so dramatic came about slowly and quietly, with no beating drums or fanfare. One psychologist wrote, quote, "The term revolution is probably inappropriate. There were no cataclysmic events. The change occurred slowly in different subfields over some 10 to 15 years. There was no identifiable flashpoint or leader in the development of cognitive psychology. Often the progression of history is clear only after the event. The founding of cognitive psychology did not occur overnight, nor could it be attributed to the charisma of one individual who, like Watson, changed the field almost single-handedly. Like functional psychology, the cognitive movement claims no solitary founder, perhaps because none of the psychologists working in the area had the personal ambition to lead a new movement. Their interest was pragmatic in nature, simply getting on with the work of redefining psychology. In retrospect, History identifies two psychologists who were not founders in the formal sense of the word, but who contributed groundbreaking work in the form of a research center and books that are now considered milestones in the development of cognitive psychology. They are George Miller and Ulrich Neisser. Their stories highlight some of the personal factors involved in shaping new schools of thought. George Miller, 1920 to 2012. George Miller was raised by his Christian Science parents to believe that psychology was a sin. And that's something that Steven Pinker, a cognitive psychologist and evolutionary psychologist, wrote in 2013. Miller grew up in West Virginia, a shy and lonely child, and went to college at the University of Alabama at Tuscaloosa, where he majored in history and speech. To overcome his shyness, he joined a drama club, an act that changed his life. He met an attractive young woman who was, to make the story complete, a psychology major. He followed her into a psychology seminar and quickly changed his mind about the field. He learned that perhaps the mind really does have power to influence things. He married the psychology major, staying on for a master's degree in speech, and was offered an instructorship to teach 16 sessions of introductory psychology, even though he had never taken a formal course in the field. He said that after teaching the same material 16 times a week, he began to believe it. Miller went on to Harvard University to work in the psychoacoustic laboratory on problems in vocal communication. In 1946, he received his PhD and 5 years later published a landmark book on psycholinguistics, which he titled Language and Communication in 1951. Initially, he accepted the behaviorist school of thought, noting that he had little choice because behaviorists held all the leadership positions in major universities and professional associations. The power, the honors, the authority, the textbooks, the money, everything in psychology was owned by the behavioristic school. Those of us who wanted to be scientific psychologists couldn't really oppose it. You just wouldn't get a job. By the mid-1950s, after investigating statistical learning theory, information theory, and computer-based models of the mind, Miller concluded that behaviorism was not, as he put it, going to work out. The similarities between the operation of computers, then still in their early days of development, and the human mind impressed him greatly. As a result, his view of psychology became more cognitively oriented. At the same time, he developed an allergy to animal hair and dander. So he had to stop doing research with laboratory rats. Working only with human subjects was a disadvantage in the world of the behaviorists who favored rats and pigeons. Of course, Miller's shift toward a cognitive psychology was also helped by his rebellious nature, so typical of many of his generation of psychologists in the 60s. They were primed to revolt against the psychology then being taught and practiced, ready to offer their new approach, their focus on cognitive rather than behavioral factors. But as Miller wrote some 50 years later, quote, "At the time it was happening, I did not realize that I was, in fact, a revolutionary," end quote. He said that in 2003. In 1956, Miller published an article now considered a classic, titled The Magical Number 7, plus or minus 2, with the subtitle, Some Limits on Our Capacity for Processing Information, end quote. As you can see, as we read earlier, that he said that he taught a 16 sections of introductory psychology, and that he had said that teaching the material 16 times a week, he began to believe it. And that was early on in his early teaching. But now, in this work titled The Magical Number 7, plus or minus 2, he demonstrated that our conscious capacity for short-term memory of numbers, or similarly for words or colors, is limited to approximately 7 chunks of information. Now, the other thing that I mentioned is that the more that you teach something, the more that you say something, the more you're likely you are to eventually believe in it. But that has to do with belief, that has to do with memory. So what Miller showed that in his work is a demonstration that our conscious capacity for short-term memory or numbers, or similarly for words or colors, is actually limited to approximately 7 what he termed chunks of information. That is all we were able to process at any given point. The importance, the impact of this finding lies in the fact that it deals with a conscious or cognitive experience at a time when behaviorism still dominated psychological thought. In addition, Miller's use of the phrase processing information indicated the influence of a computer-based model of the human mind. So, processing information. So, with Jerome Bruner, who was born in 1915 and is still alive today, his colleague at Harvard, Miller established a research center to investigate the human mind. Miller and Bruner asked the university president for space, and in 1960 they were given the house in which William James had once lived. This was considered an appropriate site because James had dealt so exquisitely in his Principles book with the nature of mental life. Choosing a name for the new enterprise was not a trivial matter. Being associated with Harvard, the center had the potential to exert an enormous influence on psychology. They selected the word cognition to denote their subject matter and decided to call the facility the Center for Cognitive Studies. In using the word cognition, we were setting ourselves off from behaviorism. We wanted something that was mental, but mental psychology seemed terribly redundant. Common sense psychology would have suggested some sort of anthropological investigation, and folk or Volk psychology would have suggested Wundt's social psychology. What word do you use to label this set of views? We chose cognition. Two students at the center later recalled that no one could tell them what cognition really meant at the time or what ideas they were supposed to be promoting. The center was not set up to be for anything in particular. It was set up to be against things. What was important was what it was not. It was not behaviorism. It was not the ruling authority, the establishment, or the psychology of the present. In defining the center, its founders were demonstrating how greatly they differed from behaviorism. As we have seen, every new movement proclaims that its position or attitude differs from the current school of thought. That is a necessary preliminary stage to defining what they are about and what changes they propose. Miller, however, gave due credit to the zeitgeist. Neither of us should take too much credit for the center's success. It was an idea whose time had merely come. That's what Miller said in 1989. Miller did not consider cognitive psychology to be a true revolution, despite its differences from behaviorism. He called it an accretion, a change by slow growth or accumulation. He saw the movement as more evolutionary than revolutionary and believed it was a return to a common sense psychology that recognized and affirmed psychology's concern with mental life as well as behavior. Researchers at the center investigated a wide range of topics, including language, memory, perception, concept formation, thinking, and developmental psychology. Most of these areas had been eliminated from the behaviorist vocabulary, but Miller later established a program for cognitive sciences at Princeton University. Miller became president of the APA in 1969 and received the Distinguished Scientific Contribution Award and the American Psychological Foundation's Gold Medal Award for life achievement in the application of psychology. In 1991, he was awarded the National Medal of Science. In 2003, he was given the APA's Outstanding Lifetime Contribution to Psychology Award. Additional acknowledgement of the significance of his work includes the number of cognitive psychology laboratories that were modeled on his center and the rapid development and formalization of the approach he did so much to define. Ulrich Neisser, 1928 to 2012. Born in Kiel, Germany, Ulrich Neisser was brought to the United States by his parents at the age of 3. Describing his childhood, Neisser wrote, "I was afraid of girls, poor at sports, and incompetent even in shop. I thought of myself as an outsider and of my few friends as weird. Maybe I was weird, too." Neisser said that in 2007. He began his college studies at Harvard, majoring in physics, but then he met George Miller, then a young psychology professor, and switched to psychology. He took an honors course with Miller on the psychology of communications and information theory. He was also influenced by Kafka's book, Principles of Gestalt Psychology. After receiving his bachelor's degree from Harvard in the year 1950, Neisser earned his master's at Swarthmore College, studying under Gestalt psychologist Wolfgang Kohler. Neisser returned to Harvard for his PhD, which he completed in 1956. Despite his growing attraction to a cognitive approach to psychology, Neisser saw no escape from behaviorism if he wanted an academic career. Quote, "It was what you had to learn. That was the age when it was supposed that no psychological phenomenon was real unless you can demonstrate it in a rat." End quote. It was fortunate that his first academic job was at Brandeis, where the psychology department chair was Abraham Maslow, who was then moving away from his own behaviorist training to develop the humanistic approach to the field. Maslow was not successful in turning Neisser into a humanistic psychologist or in turning humanistic psychology into psychology's third force, but he provided the opportunity for Neisser to pursue his interest in cognitive issues. Neisser later claimed that cognitive psychology, not humanistic psychology, was the third force. In defining himself in 1967, Neisser published a book called Cognitive Psychology. He said the book was highly personal and attempted to define himself and the kind of psychologist he wanted to be. The book was also a landmark in the history of psychology, an attempt to define a new approach to the field. It became extremely popular, and Neisser was embarrassed to find himself designated the father of cognitive psychology. But in the blink of an eye, Neisser wrote 40 years later, there were cognitive journals, courses on cognition, training programs in cognitive psychology, and conferences of every kind. I myself was a star, now introduced everywhere as the father of cognitive psychology. It was a heady experience for a young man not yet 40 years old. And that is from Neisser in 2007. Despite such adulation, he soon grew disillusioned with what he had created. Just 9 years later, Neisser published Cognition and Reality, a book in 1976, which expressed his deepening dissatisfaction with what he saw as the narrowing of the cognitive position and its reliance on laboratory situations instead of real-world settings from which to collect data. He insisted that the results of psychological research should have ecological validity. By that, he meant that they should be generalizable to situations beyond the confines of the lab. In addition, Neisser insisted that cognitive psychologists be able to apply their findings to practical problems, helping people deal with everyday issues in their work and in their lives. Thus, Neisser concluded that the cognitive psychology movement had little to contribute to psychology's understanding of how people cope in the real world, and so this major figure in the founding of cognitive psychology became an outspoken critic of his own school, movement. And he challenged the movement as he had earlier challenged behaviorism. After 17 years at Cornell University, where his office was not far from where Titchener's pickled brain was housed, Neisser moved to Emory University in Atlanta, in Georgia. He returned to Cornell in 1996 and remained there until his death in 2012. As we saw earlier, that clocks were the 17th century metaphors for the mechanical view of the universe, and by extension for the human mind. Those mechanical devices were widespread, easily understood models of how the mind was believed to work, like a clockwork, like the different moving parts of a wristwatch. Today, the mechanical model of the universe and the behavioral psychology that derived from it have been superseded by other viewpoints, including the acceptance of subjectivity in physics and the cognitive movement in psychology. As a result, the clock is no longer a useful example for the modern view of the mind. To replace it, a 20th century machine, the computer, has emerged to serve as our model, as a new metaphor for the functioning of the mind. One historian of science wrote, quote, "The vehicle for the reintroduction of mind and a vital agent of behaviorism's overthrow was the idea that the brain is a computer. This assertion has become a commonplace one in the historical literature on the cognitive revolution." End quote. Psychologists invoke the operations of the computer to explain cognitive phenomena. Computers, said to display artificial intelligence, or AI, are often described in human terms. The storage capacity is its memory. Programming codes are languages, and new generations of computers are said to be evolving. Computer programs, essential sets of instructions for dealing with symbols, may be seen to function similarly to the human mind. Both the computer and the mind receive inputs from the environment in the form of large amounts of information, sensory stimuli, or data. They suggest this information, manipulating, storing, and retrieving it, and acting on it in various ways. Thus, computer programming has become the basis for the cognitive view of human information processing, reasoning, and problem solving. Cognitive psychologists are interested in the sequence of symbol manipulation that underlies human thought processes. In other words, they are concerned with how the mind processes information. Their goal is to discover the program each of us has stored in our memory, those patterns of thinking that allow us to understand and articulate ideas, to remember and recall events and concepts, and to grasp and solve new problems. In more than 125 years of history, psychology has progressed from simple clocks to sophisticated computers as the models for its subject matter, but it is significant that both are mechanical. As early as 1982, Time magazine declared that the personal computer was the, quote, machine of the year. And this continuation of the mechanical model demonstrates the historical continuity in psychology's evolution from older to newer schools of thought. We can also understand a historical continuity in the evolution of computers themselves. We saw earlier how Charles Babbage and Henry Hollerith developed machines that would think like humans. However, it was a vexing practical problem during the early days of World War II that led to the beginnings of the modern age of computers. One only think of the life of Alan Turing from 1912 to 1954 and the Turing machine, as well as the Turing test. In 1942, the United States Army desperately needed to find a faster way to make the rapid calculations required to fire artillery pieces. To aim cannon accurately so that the shell hits its target was a difficult process, far more complex than a soldier aiming a rifle and squeezing the trigger. To aim a cannon, a gunner had to adjust the gun to several settings. That required mathematical tables to account for all the variables that affect the trajectory of an artillery shell: wind speed and direction, humidity, temperature, elevation, even the temperature of the gunpowder. The book of settings for each type of artillery piece contained hundreds, even thousands of tables of settings. Just one single trajectory required 12 hours of continuous and complicated calculations. This work was carried out by women newly employed during wartime using mechanical calculating machines. The women holding these jobs were called computers. Within a year, however, they had fallen behind and could not keep up with the demand. The situation was so critical that some cannon had to be withdrawn from combat because there were no firing tables available. This need spurred the development of the first giant computer, the Electronic Numerical Integrator and Calculator, ENIAC. Completed in 1943, the horseshoe-shaped machine took up 3 walls of a huge room with arms 80 feet long. It would stand 8 feet tall and weigh 30 tons. It would contain 17,468 vacuum tubes, as well as 10,000 capacitors, 70,000 resistors, 1,500 relays, and 6,000 manual switches. An array of electronics so vast that large blowers would be required to dissipate the heat it produced. By the year 1951, a faster and smaller computer was developed called the Mathematical and Numerical Integrator and Computer, more popularly known as MANIAC, MANIAC. It weighed 1,000 pounds and was only 6 feet high and 8 feet long. Machines that can perform mental operations have come a long way from Babbage's calculating engine. You need only to compare the size and capacity of your laptop or smartphone to realize how primitive ENIAC and MANIAC were. Any laptop today is about 100,000 times faster than the MANIAC. The evolution of machines to perform mental functions continues at a rapid pace, which leads inevitably to the question of whether these machines truly demonstrate intelligence. We noted that cognitive psychologists accepted computers as a model for human cognitive functioning. suggesting that the machines display artificial intelligence and process information similarly to the way people do. Does it follow that the computer's intelligence is the same as human intelligence? Can computers think? Absolutely, they can think. In the 17th century, automata simulated human movements and speech. In the future, will new generations of computers stimulate human thought? Initially, computer scientists and cognitive psychologists embraced the notion of artificial intelligence. In 1949, when computers were relatively primitive, the author of a book titled Giant Brains declared, "A machine can handle information, it can calculate, conclude, and choose. It can perform reasonable operations with information. It can program itself. A machine, therefore, can think." In 1950, the British computer genius Alan Turing proposed to find out if that was true. And obviously we know that some computers actually can perform way better than humans can, and humans and machines at some point in time may be more conscious than actual humans themselves.